The cube below has an internal diagonal of length 20 centimeters. Each edge of the cube is of length x centimeters. Calculate the value of x. Okay, so we want a value, right? Notice there it says value. So we're going to get a numerical answer here, okay? And they've told us this cube here, the size of x. So I can write x there, can't I? And just looking at this, you've got to ask yourself, what methods could I use here? You know, you could look volume of the cube is x times x times x, right? Which is x cubed. Is that going to help you? Probably not, because they haven't told us what the volume is, haven't they? They haven't told us anything about the volume. All they've done is given us this diagonal here, going from top corner to bottom corner. That's all. And we can't get the volume from there, so that maybe won't help. So you've got to think outside the box. You've got to think about trigonometry, Pythagoras, right? And in this case, I'm looking at Pythagoras, because if you look at the base here, can we see a triangle that's been formed? I'm trying to draw a right angle here, okay? But you've got there's your hypotenuse, isn't it? Okay, and your two sides, the sides of the cube here, the edges here, okay, x and x. And you've got that base diagonal there, that dotted line, right? That's Pythagoras, isn't it? And with Pythagoras, of course, a squared plus b squared equals c squared. Now your a and your b are those two sides, so that'll be x squared plus the b there, which is x squared, will equal this side here, c squared. Okay, so that would be 2x squared is c squared. Alright? And you could work out c from there, couldn't you? You could work out c, so you could actually work out the length of this by taking the square over and square rooting. Okay? Okay, you could get that there, square root of 2x squared. Okay? We could go further with that. We could simplify this even further, I suppose, because you've got square root of 2x squared. Well, you could split this up, because, you know, if you think about it, square root of 2, well, okay, I don't know what that is a irrational number. Square root of x squared is just x, isn't it? Yeah? Square root of x squared is just x. Because when you square root a square number, you get back to the original number. Okay, so this here is root 2 times x. Okay? Now, can we see another triangle? Pythagoras again. Notice now there's like a vertical triangle, where this now is your hypotenuse. This is your hypotenuse. Okay? You've got your dotted line as one of the smaller sides. You've got this vertical edge here as another side, and you've got your hypotenuse there. So you're going to have Pythagoras again. This time you'll have this squared, x squared, plus this squared. Okay? Now if we square this, right, you'll have 2 x squared, won't you? Okay, it's just like that, isn't it? There, basically, you can go back to that version of it. Remember that? Remember we called it c before? This side? You square it, is 2x squared. And that will equal, of course, this squared, which is 20 squared. Right? This becomes 3x squared. 20 squared on your calculator, if you don't know, 400 squared. And then you've just got to solve this, okay? So then x squared is 400. Well, because you times it by 3, take it over and divide. So x squared would be 400 divided by 3. You know, 133.3 recurring. And of course, to get x, you just got to square root this answer. That's what I'll do on my calculator one. I'll just do square root ants, and I get my answer out then to be that. Okay, so we can put it, if you want, 11.547. That looks kind of a nice cut-off point actually, because you've got zeros there to 3 decimal places.